Okay, right now, a method declared inside abstract class with at the rate abstract method. Decorator is called as an abstract method. I said abstract method doesn't have implementation in base class. So its implementation is given in which class here? Derived class, right? So I said abstract method is an empty method. If more than one class having similar role with a different implementation, then it is declared as which method here? Abstract method. I said you can use an abstract class and abstract methods. Abstract class is used only for inheriting, but not for creating objects. So cannot create object. So you can say abstract class is an abstract data type. You can say abstract class is a abstract data type. Abstract class is called as an abstract data type. So here abstract class. So here abstract class is called as an abstract data type. So a data type which allows to build a similar data types is called abstract data type. What is an abstract data type is a data type which allows build similar data types is called abstract data type. For example, in application development, so what will happen in application development here is, suppose, assume that suppose there is a class. So when I should go for abstract classes and abstract methods means, for example, if you take, so there is one class. So what is the name of this class here? Triangle. So triangle is a class. Okay, triangle is a class. If we take triangle is a class, and what triangle is having? Some triangle is having two dimensions. So assume that there is a dimension 1 and there is a dimension 2. So that is nothing but base and height of the triangle. Okay. So there is one more class is there. What is this here? Rectangle. And this rectangle again having two dimensions. So that is dimension 1 and dimension 2. So that is nothing but length and breadth. So triangle is having two dimensions and rectangle also have two dimensions. So I read the dimensions of the triangle by using a method called read. So using this method, you are trying to read. So what you are trying to read? Dimension 1. You are trying to read dimension 1. Self dot dimension 2. You are trying to read dimension 2. In the same way, I try to read the dimensions of rectangle by using a method called which one? Read. So this read method is belongs to which class? Triangle, which read the dimension 1 and dimension 2 of triangle. And this read method belongs to which one? Rectangle. And this reads the dimension 1, dimension 2 of rectangle. So there is a method. Okay, there is a method called which one? Find area. So this written, what it returns here, dimension 1 and 0.5 into self dot dimension 1 into self dot dimension 2. So this will return area of the triangle. And this is also have a method called find area. Okay. And this will find the area of rectangle. So where I'm saying self dot dimension 1, self dot dimension 1 into self dot dimension 2. So how many classes are there here? Two classes. One is a triangle and one more is a rectangle. But if you see these two classes, there are certain things which are common, right? So triangle is having 2 dimensions and rectangle is also have 2 dimensions. The way how you are reading the dimension of triangle, in the same way you are reading dimension of rectangle. Okay, it means these both the classes are similar type or different type? Similar type, because they are sharing the same properties or not? Yes. So when more than one class share the same properties and behavior, you write those properties and behavior how many times? Only one time. You write that properties and behavior how many times? Only one time. So what is the name of this class here? Some shape. So your shape is a class. And this class define the properties of what? Triangle and rectangle. So every shape is having how many dimensions? 2 dimensions. So that is, I define dimension 1 and dimension 2. Okay, so we are writing this variables how many times? One time. We are writing this variables how many times? One time. And this triangle is derived from which class? Shape class. And rectangle is derived from which class? Shape class. So here I don't require to write these variables again. So how many times you are declaring these variables? One time. And you are using these variables how many times here? More than one time. Then you are reading the dimensions of the triangle. And how you are reading the dimensions of the triangle? By using a method called read. So I'm writing self dot, self dot dimension 1 equal to float of input. So reading the values of dimension 1, self dot dimension 2, float of, input. So this is reading dimensions of, now is it this method implementation is the same or not? Yes. If more than one class is having same variables, if more than one class is having same variables, if more than one class is having same method, you are writing that variables how many times? One time. You are writing method how many times? One time. And you are using how many times here? Two times. Now this method is used by triangle, and this method also used by what? Rectangle, to read the dimensions of triangle and to read the dimensions of what? Rectangle. But there is one method which is same. There is a method which is same, but is it implementation of this method is the same? No. Method name is the same, but implementation is not same. But here method name is the same and implementation is also same. Then you are writing the code how many times? One time. One time, and you are using how many times? Two times, right? But here method name is the same, but implementation is not same. Then you declare this method. Then you declare this method as what here? Abstract. You declare this method as which method here? Abstract method. So when more than one class having same method but with different implementation, having same method is the same but implementation is what? Different. Then you declare that method as what? Abstract method. Okay, method name is the same but implementation is what? Different. So when you declare the method as an abstract is a more than one class, a more than one subclass having similar role, a more than one subclass is having similar role with a different implementation, then you declare that method as what? Abstract. But when more than one class is having same implementation, you are writing that implementation how many times? One time, and it is used how many times? More than one time. Okay, so then you declare this shape class as which class? Abstract class. So it inherit which class here? ABC class. So any class which is derived from ABC class, it is called as which class here? Abstract base class. Any class which is derived from ABC class is called as which class here? Abstract base class. Now see here. So we'll try to write same example here, right? So I try to import a module. So what is this module here? ABC module. And what is the name of the class? Shape class. ABC dot ABC. Now here I am writing a constructor, and this constructor define the properties. So I make this variables as a protected. So protected variables are accessible within the same class, and it is also accessible in which class? Derived class. Okay. Protectors are accessible within the same class, and these are accessible within the derived class also. So dimension 1 and there is a dimension 2. So now shape is having how many dimensions here? 2 dimensions. So that is a dimension 1 and one more is a dimension 2. And you are reading the dimensions of this every shape by using a read. So single underscore means protected. Okay, input. What should I input here? Dimension 1. Okay, self dot. Okay, dimension 2. So float of input. So what you are trying to input here? Dimension. Then at the rate ABC dot, what I am writing here? Abstract method. So there is an abstract method called which one? Find area. Okay. So this method is what here? Abstract. This method is what here? Abstract method. Okay. So the method which doesn't have implementation in the same class, but this implementation must be given in which class? Derived class. So there is a class and there is a shape. Okay, there is a shape called which one? Triangle. So triangle is a shape. Now this triangle, call the constructor of which class? Super class by saying super dot in it. So this call the constructor of super class and override which method? Find area. Now this is called as which method? Overriding method. This is called as which method here? Overriding method. So where I'm saying return self dot dimension 1 into self dot, actually self dot dimension 1 into self dot dimension 2 into 0.5. Now that is nothing but base into height into half into base into height, right? So there is a class. What is the class now? Rectangle. I am developing one more shape. What is the name of this shape here? Rectangle. Okay. And this is also inherits the properties of which class? Superclass. By saying super dot, I called which method in it. Then I try to override again which method? Find area. So this is called as which method? Overriding method. So where I'm saying return self dot dimension 1 into self dot dimension 2. So here this properties and method is a common, but this is also common for all shapes. There should be what? Find area. But how to find the area must be defined by the person who develop a shape. When you develop a rectangle, you write the implementation of what? Find area. When you develop a rectangle, you write the implementation of what? Find area. What is it? Find area implementation is there in the shape? No, because it is not a same implementation. It is a different implementation for every class. It is not a same implementation. It is a different implementation for every class. So I create which object here? Triangle object. I create which object here? Rectangle object. So how many objects I created here? Two objects. So that is T1 and one more is what? R1. I'm saying T1 dot read. Okay. And after that I'm saying area 1 equal to T1 dot find area. Okay. So this is area of a triangle. So I try to display the area 1 with number of decimal places and R1 dot read. So this is reading values of rectangle. Then area 2 equal to R1 dot find it. See here. Okay. So when I say T1 dot find area, it look for find area method in triangle. When I say T1 dot read, it look for read method in what? Triangle. What is it? Read method is there in triangle? No. But for triangle, which one is a superclass? Shape. So is it read method is there in shape? Yes. So that will read the dimension 1 and dimension 2 of which one? Triangle, right? So I'm trying to print the format area of a rectangle. I just display the area 2, okay, with how many decimal places? 2 here. So once you run this, okay, now you can see class name. So now you can see dimension 1 and dimension 2. Now this you can call it as area of the triangle. So dimension 1 and dimension 2, and this you can call it as area of which one? Rectangle. So using shape class, I build how many types of shapes here? 2 types. One is a triangle and one more is what? Rectangle. Not only that, I said no, abstract classes define some set of rules and regulations. So here abstracts are used by, okay, three people or 3 programs. Abstracts are used by 2 programs here. Abstracts are used by, okay, 2 programs. One is called as a, okay, implementer. One is called as an implementer. One is called as an implementer and one more is called as a caller. Abstracts are used by how many programs here? Two one is called as implementer and one more is called as which one? Caller. Abstracts are used by two programs. One is implementer and one more is a caller. These rules are followed by it. Is just like abstracts are just like an API. Okay, generally you call it as API. API stands for Application Programming Interface. It is an interface between caller. It is interface between the caller and what is that? Implementer. See here. What is the meaning of this is, for example, a basic example, if you see it, suppose assume that RBI, for example, RBI, which define or which gives the abstracts, RBI gives an abstracts, RBI gives an abstracts for developing debit card. How to develop a debit card? That rules are given by whom? RBI. It means RBI is given some abstracts. How to develop a debit card? How to develop a debit card? That abstracts are given by whom? RBI. How to develop a debit card? So there is a debit card. And what is a debit card here? Abstract base class. RBI says that every debit card, RBI says that every debit card must have one abstract method. Every debit card must have one abstract method or one method called which one? Withdraw. RBI says that every debit card must have a withdraw. Okay, but the implementation of this withdraw is given by which people? The people who develop which one? Debit cards. For example, you have a bank. So there is a bank called which one? SDFC is there. Now SDFC want to develop a debit card for their customers. But how they develop debit cards for their customers? By following the rules given by whom? RBI. By following the rules given by whom? RBI. SDFC debit card inherits what here? Debit card. SDFC debit card inherits a debit card here. Okay. There's a class. What is the name of this here? SDFC debit card. SDFC debit card. Okay, inherits which class here? Debit card, because it is developed by following the rules given by whom? RBI. So must provide the implementation of which one? Withdraw. Now here you write the logic of withdrawing from which bank? HDFC. Okay, assume that HDFC allows to withdraw this. Assume that HDFC allows to withdraw some 50,000 per day. Assume that HDFC allows to withdraw some 50,000 per day. Now this is the implementation of which one? HDFC. Okay, there is one more bank is there. So there is one more bank. What is that here? SBI is there. So there is a class. Okay, there is a class, and what is this class here? SBI debit card. So SBI debit card is what again? Debit card. SBI debit card is a debit card, and this SBI debit card must override which method? Withdraw again. Because the class which inherits abstract class must override which method? Abstract method. Okay. Okay, assume that SBI debit card allows to withdraw some 20,000 per day. Now this is the implementation of which one? SBI. And this is the implementation of which one? SDFC. And where these debit cards are used, assume that it is used in one ATM. where you are using this debit cards in ATM. ATM will be there. Okay, assume that there is an ATM. Which ATM? Assume that ICICI. So they are building one ATM. Okay, they build one ATM. What is this ATM? ICICI ATM. But this ICICI ATM should allow to withdraw from any debit card or only ICICI debit card, any debit card. Then any debit card means it should follow the rules given by whom? RBI. Now who's using these rules? Caller. Because who's calling the functions of this debit card? ATM. Okay, so these abstracts are used by how many people here? Two people. One is implementer and one more is a caller. So it means caller is calling the methods of which class? Abstract class. So that is called as a encapsulation again. Hiding the implementations details. Hiding the implementation details. Which details are hidden here? Implementations are hidden. Only which one is given? Abstracts are given. Okay, so the person who's developing ATM, he doesn't know the implementation of HDFC or implementation of what? SBI. He knows only which one? He knows only which one? Abstracts. Caller doesn't know. Okay, caller doesn't know the implementations. Caller knows only which one? Specifications. Caller knows only specification. He doesn't know which one? Implementations are hidden. That is what you mean by abstraction again. Hiding the implementation details by just giving only which one? Specifications. So caller is calling. Suppose within ATM you insert. What do you insert here? Debit card. But which debit card? Any debit card or not? Yes. This is called as duck typing. Okay. Now D dot, you'll say D dot. So this is self comma D dot. D dot which one? Withdraw. So ATM is calling which method? Withdraw method of which one? Debit card. But which debit card? Any debit card which is having which method? Withdraw method. So that can be either HDFC, that can be either what? SBI. It means caller is calling the implementations. Caller is calling the implementations using abstracts. Caller is calling the implementations using which one? Abstracts. Now this is application programming interface. So how caller is calling? By using which one? Implementations. Okay, so using this method, using these rules, you can call the implementations of either SBI or you may call the implementations of either SDFs. But caller knows only the methods of which one? Debit card. But he knows any implementations of debit card? No. So these implementations are hidden from whom? Caller. So that you can call it as again encapsulation, and the same thing can be called as an abstraction also. Now using abstract classes and abstract methods, even you can achieve what? Abstraction. Okay, abstraction means hiding the implementations but giving only which one? Specifications. See here, only specifications are given. Withdraw method is given without knowing which details? Implementation details. Okay, how to implement this here? So this is called as a duck typing. So what is a duck typing here? See here, what is duck typing? So what is a duck typing here is a programming style which doesn't look at the, yes, what is a duck typing? What is a duck typing is a programming style. What is a duck typing is a programming style which doesn't look at an object's type to determine if it has the right interface. Instead of the method or attribute is simply called or used. If it looks like a duck and quacks like a duck, it must be what? Duck. Okay, it means in this case, you are calling just a method of which one? Withdraw. You are calling withdraw method of which object? Debit card object. But you are not looking, is it this is debit card or not? But any card which is having withdraw, is just call it. Any object which is having withdraw is just call it without looking at which one object type. Either it is SDFC or what? SBI. Any card which is having withdraw, it just call it. Yes, here it will assume that any card which is having withdraw is called which one? Debit card. Or it might be debit card or it might be credit card. Because credit card also having which method? Withdraw. Okay, now see here. A programming style which doesn't look at an object's type to determine if it has the right interface. Instead of the method or attribute is simply called or what? Used. If it looks like a duck and quacks like a duck, it must be what? Duck. Okay, right? Yes. Now, what is the advantage of this? Developing loosely coupled code. So the advantage of duck typing is to develop loosely coupled code. Okay, loosely coupled code. What is the advantage of this is developing which code? Loosely coupled code. Okay, correct only. Developing loosely coupled code means the code which work with any type. The code which work with any type. Any type is called as which one? Loosely coupled code. The code which work with any type. The code which work with any type. So that is called as which code? Loosely coupled code. Which work with any type. The code which work with any type. So that code is called loosely coupled code. Okay, right now that is what you mean by duck typing here. Yes, that is the meaning of duck typing here. Okay, right. Okay, right now, then next try to see here. Now, how to implement this example here. So what I'm doing is I'm trying to say import ABC. Okay, now this is how generally you work with the frameworks like Django, right? Now, if you take Django is a framework, right? And what it define abstracts. Okay, what it define here abstract. Suppose framework define like how to develop a model. Django define how to develop model, and Django define how to develop a view, and Django define how to develop a template. So these abstracts are given by which one? Django. Then you develop model, you develop view, and you develop which one? Template. Then who execute this? There is a Django engine. So what is this here? Django container or Django, what is that? Engine. So it will try to execute any model, any view, and any template. Because all this model, view, and template, all these are developed by following the rules given by whom? Design. All these are developed by following the rules given by which one? Design. So it means this is giving which one? API. Okay. So what it defining? It defining some abstracts. Now using these abstracts, you are calling which one? Implementations. So that can be a student model, that can be a student view, or that can be a student template. So that can be employee model, that can be employee view, that can be employee template. Anything it is. Anything it is, right? Okay. Just try to understand. So this is where frameworks work. Okay. So there is a ABC module, and here I'm developing one. So here I'm developing one class. So what is a class now? Some debit card. Or suppose, okay, I'll take another example. So there is a class. What is the name of the class? Sim is there. Now sim is an abstract. Okay, but these are, this is having some abstract method called, every sim must have one method called, every sim must have one method called which one? Connect. So, but the implementation of this connect varies from one sim to another. Okay, so who's implementing this connect method? SIM manufacturers. Okay, assume that there is a Airtel SIM. Airtel SIM is what here? SIM. Okay, Airtel SIM is a SIM and provide the implementation of which method? Connect method. And this will connect it to which network? Airtel network. So connect to which network here? Airtel network. Connected to Airtel network. So there is another SIM called BSNL SIM. Okay. And this also follow the rules given by whom? Try. Okay. And this connected to which is SIM here? Which network? BSNL network. So connected to BSNL network. BSNL network. So there is a class. Another SIM is there, that is Geo SIM is inherit from which one? SIM again. So all these are implementations. Okay, now there is a override method called connect. So this is connected to which network? Geo network. This connected to which network? Geo network. See, how many types of SIMs are there here? 3 types. But who call the functions of SIM? Mobile. Who calls the functions of SIM? Mobile. Now there is a mobile class. So this is a class. What is the name of this class? Mobile. So mobile calls the functions of which one? SIM. But which SIM? Any SIM. Is it your mobile work with one type of SIM or any SIM? Any SIM. Any SIM, right? Okay, now there is a method called insert. Where in mobile I'll try to insert what here? SIM. Once I insert SIM, it just connected to a specific network or not? Yes. By calling which method here? Connect method. By calling which method here? Connect method. So who's implementing this abstracts? SIM manufacturers. Who's calling this abstracts? Mobile manufacturers. Now this is a caller and this is what here? Implementer. This is a caller and this is what here? Implementer, right? Then what I'm doing, I'm creating object of which one? Mobile. Okay, I'm creating object of mobile. So there is a mobile one. So mobile one is there. I created one mobile one object. Then I'm creating number of SIM objects. Now there is a Airtel SIM object. This is S1 is Airtel SIM object. S2 is what here? BSNL SIM object. Okay, Airtel SIM object, BSNL SIM object. And S3 is what here? Geo SIM object. So I created how many SIM objects here? 3. And how many mobile objects I created? 1. Okay, this is, for example, assume that, okay, any mobile you can take here. Okay, any mobile, but what is the name of this object? Mobile 1. So what I'm doing, I'm saying mobile 1 dot insert. What I insert here? S1. S1 is the object of which type here? Airtel. S1 is the object of which one? Airtel. Airtel object, right? Then it just connect to which network? Airtel network. Suppose I remove this S1. Now this time I am trying to insert which one? S2. Then what will happen? Now this S2 object is received by which one? S. And if you say S dot connect, now S is holding which object? S is holding which object? S2 object. S2 is which object? BSNL. Then it will call the connect method of what? BSNL. Then it connects to which network? BSNL network. If I say insert, now one mobile, is it working with only one SIM or any SIM? Any SIM. You can see connected to which network here? Geo network. Now this S3 object is sent to which one? Insert. Now this time S is holding the address of which object? S3 object and then connected to which network? Geo net. It means this code is working with only one object or any object. Any object having which method? Insert method. So this insert method is it looking for type? No, it's just calling which method? Connect method of which object? S object. But this S object can be either SIM object or it can be any other object having which method? Connect method. That is called as which one? Duck typing. A programming style which doesn't look at an object's type to determine if it has a right interface, instead of the method or attribute is simply called or what? Used. Like if it looks like a duck and quacks like a duck, it must be duck. But you are not checking, is it that is a duck or not? Okay, right? So the advantage of duck typing is to develop loosely coupled code. The code which work with any type is called as which one? Loosely coupled code. Is called which one here? Loosely coupled code. The code which work with any type. So that code is called loosely coupled code. Now you can also write this example. You can also write this example also like debit card and ATM. This example also you can implement it. Now this is how you work with an abstract class. But I said, no, you cannot create object of abstract class. If I'm writing, if I'm creating object of sim is only which one? Abstract. And you cannot create object of abstract class here. So there is an error here. What is that type error? Cannot instantiate abstract class sim with an abstract method what here? Connect. So is it possible to create an object of an abstract class? No. You cannot create object of which class? Abstract class. So it is given one error saying that cannot instantiate abstract class sim with an abstract method what here? Connect. So if we are trying to do that, immediately it gives what here? Error, right? Yes. So this is about how you are working with the classes and object. Now I said you about working with which one? Encapsulation, and second one is inheritance. Third one is polymorphism. Okay. And I said what is a class, and I said what is a objectives. So what is encapsulation? It is a process of what? Grouping data and operations within one single entity. So that is called as which one? Inheritance, encapsulation. Binding data with, or you'll say binding data with related operations is called which one? Encapsulation. Okay. And what is inheritance? Acquiring the properties of one class inside another class is called inheritance. So which provide the reusability. Polymorphism, defining one thing in many forms. Many forms is called which one? Polymorphism. Okay, this is achieved or this is implemented using which concept here? Method what? Overriding. Polymorphism, and this is implemented using, yes, class represents one data type, or it represents which data type? User defined data type. An object is an implementation of a class. Implementation of class, or class allocates memory for objects. Class allocates memory for object. For every object behind there is one class. So these are definitions here. What is encapsulation? Okay. And what is inheritance? Okay. What is inheritance? And what is a polymorphism? And next one is what is a class? And next one is what is a object is. So what is an abstraction here? Abstraction also there. So abstraction is nothing but hiding the implementations by revealing what here? Specifications. Hiding the essential features of object. Hiding the essential features of the object and giving only required things. That you can call it as abstraction. Abstraction in object oriented. See, abstraction is a process of hiding the internal details of application from outer world. Abstraction is used to describe the things in simple terms. It's used to create a boundary between the application and client program. That is what I said. It is just like an interface. It is just like which one? Interface. How you are achieving this here? By using abstract classes and abstract methods. This is one definition of which one? Abstraction. So this is what what is called as a abstraction here. Okay, in object oriented way, right? Okay, right? Now these are some of the definitions of object oriented encapsulation, inheritance, polymorphism. There is a class and there is an object, and one more is a abstraction. What is the advantage? What is the advantage of object oriented programming? What is the advantage of object oriented programming? Modularity. What is the advantage of object oriented programming? Reusability. What is the advantage of object oriented readability? What is the advantage of object oriented efficiency? The advantage of object oriented is security. Modularity is achieved by using what? Encapsulation, and one more is a inheritance. So reusability is done by using which one? Inheritance. Readability is done by using again encapsulation. So encapsulation as well as what? Inheritance. You are dividing, right? Efficiency using all concepts of which one? Object oriented. Security is achieved by using encapsulation. What is the advantage of encapsulation? Data hiding. And that is done by using which one? Encapsulation. So what is the advantage of object oriented is modularity, reusability, readability, efficiency, and one more is a security. Modularity is achieved by using encapsulation and inheritance. Reusability is achieved by using inheritance. Readability is achieved using encapsulation and inheritance, because you are trying to divide your application into a number of classes. By dividing into a number of classes, you can easily understand, right? Maintain the code. Efficiency is achieved by using all principles of what? Object oriented, and security is achieved by using encapsulation. Okay, right. Then you can also write a class inside a class. You can write a class inside a class, and that is called as an inner class or what? Nested class. You can also write a class inside a class. Okay, object oriented is not over. Okay, now you can write a class inside a class, and writing a class inside a class is called as an inner class or what? Nested class. So the way how you are writing a for loop inside a for loop, if you are writing a for loop inside a for loop is called which one? Nested for. If you are writing a while loop inside a while loop, it is called nested while. In the same way, if you are writing a class inside a class, then it is called which class? Inner class or nested class. So a class defined inside a class is called which class here? Inner class, or it is called as a nested class. A class defined inside class. If you are writing a class inside a class, then it is called as inner class. It is called as inner class, or it is called as which one? Nested class. Okay. But what is the need of inner class or nested class? Okay. That is, so hiding implementation of hiding implementation of one class inside another class. You want to hiding implementation of one class inside another class. Okay, is done using inner classes. Using what here? Inner classes or using nested class. I want to write one class. For example, I want to write one class. Suppose, assume that there is a class A is there. I want this class A should use only by one class. I want this class A should used by only which class? B class. But this class A should not used by any other class. But if you write class A outside, then this class can used by A class as well as what? C class. B class as well as C class. But I don't want this class A should used by which class? C class. Then what do you do it? You write this class A inside which class? B class. It means this class A is there inside which class? B class. Then A class is used only in which class? B class. But you cannot use A class inside which class? C class. So who can use the implementation of A class only? B class. But the A class implementation cannot used by any other class. It's nothing but creating a class as a member of another class. It's called as a nested class or inner class. Defining a class as a member. Generally, we declare variables and methods as what? Member. But this time we are creating which one as a member? Class. Defining class as a member. Defining a class as a member of another class is called which class here? Inner class, or is called as which one? Nested class. So this nested classes can be member class or it can be which one? Local class. So this can be, how many types of inner classes are there? Two types. One is called as a member class and other one is called as which one? Local class. Member class. Member class. It can be two types here. One is a member class and one more is what? Local class. Okay, one is a member class and one more is a local class. You have two classes here. One is a member class and one more is a local class. So member class. So defining a class inside class as a member is called which class here? Member class. Okay, now this is class level member actually. This is which member here? Class level. What is the meaning of this is how you are writing this. Now see here, this is a syntax of writing a member class. How you are writing, there is a class, you are writing like this. Class and class name or class type name. You are writing a class and it followed by what name? Class name or class type name. And inside this class, you are writing immediately one class. So this class is a member of which one? This class, right? So this you can call it as which class? Member class. Okay, so top level class. Now you can call this as which class? Outer class. Then you can call this as which class? Inner class. But which type of inner class it is? Member class. And inside this class, you can write the variables. Inside this class, you can write what here? Methods. Inside this class, you can write variables and what is that? Methods. Inside this class, you can write the variables and methods. So this is outer class name and this is what here? Inner class name. And this outer class is having its own variables and what is that? Methods. Outer class is having its own variables and methods. So member class is used. Member class is used within which class here? Outer class, but cannot accessible outside the outer class. Cannot accessible outside the outer class. Member class is used within outer class. Member class is used within outer class, but cannot accessible where? Outside the outer class. Cannot access it outside the outer class. It is accessible only within the outer class. Means where you create object of this member class within outer class. Okay. Object of member class is created. Object of member class is created within. So within which class here? Outer class. Object of member class is created within outer class, but not outside the outer class. Object of member class is created within which class? Outer class, but not outside the outer class. So what is the meaning of this? For example, so there is a class. What is the name of this class is? Assume that there is a class, which one? A. Within class A, I write another class called which one? B. So A class is called as which class? Outer class. And B class is called as which class? Inner class. But which type of inner class? Member class. So this is having one method called M1. So this is M1 of which class? B class. So there is a method called M2. Where is the method M2? Is it M2 is a method of which class? A class. Now M2 method of A class want to call M1 method of which class? B class. But M1 is which method? Object level method or not? Yes. This is which method here? Object level method. An object level method always bind with what? Object name. So to call this M1 method, I need to create object of which class? B class. But where I can create object of B class? Within A class. Okay, now M2 method create object of which class? B class by saying A dot B. Where is B? It is a class level or not? Yes. Then class level is accessed with what name? Class name. So you are creating object of which class? B class. And where is a B class inside which class? A class. So created object of B class exists in which class? A class. And then I say obj B dot M1. So this is M2 method of. This is M2 of which class? A class. Now here I create object of which class? A class. I create object of which class? A class. And after creating object of A class, I call which method? M2 method. So called M2 method of which class? A class. And that create object of which class? B class. And call M1 method of which class? B class. But where is a B class? Is it B class is there outside or within? Within. B class is not there outside. B class is there within A class. Now, once you run this, you can see M1 of which class? B class. And M2 of which class? A class. So instead of creating engine outside the car, you try to create an engine within the car so that I can use that engine only within which class? Car class, but not in any other class. Okay, you are hiding. Means that engine is hidden within which class here? Car class as a member. You are writing it as a member here, right? So it is used by only one object, or it is used by only the same class, but cannot used by any other class. What is the meaning of this here? For example, this is what I'm saying. There is a class. What is the name of this? Car is it? There is a class. What is the name of this here? Engine. So where is the engine? Within car, not outside. Anyways, who can use the functions of engine? Only car. Okay. So there is a method called which one? Start. So here I'll try to display engine. Engine what here? Start. Engine start. There is one method called which one? Stop. So where I'm saying engine, engine what is this? Stop. Okay, now there is a car. Car is having constructor, and within constructor I'm creating object of which one? Engine. So car dot, what is the object I created? Engine. Okay, then when I start the car, then I should call the start function of which one? Engine. So engine dot which one? Start. So there is a method called which one? Stop. Okay, then I'm saying self dot engine dot stop. But here I create object of which class? Engine class. But where is the engine in? Within the car. So is it a class level member or not? Yes. This is a class level member, and I'm creating object of this class level member. I'm creating object of this class level member inside which class? Outer class. But is it this engine is visible outside the car? No. This engine is not visible outside the car. So this engine is hidden within what? Car. This engine is not visible outside the car. It is hidden within the car. So I create object of car. I create object of car by saying car1 equal to car. Then I'll say car1 dot which one? Start. Car1 dot which one? Stop. So when I say car1 dot start, it just call the start method of which one? Car. But that will call the start method of which one? Engine. But where is the engine type? Within the car. So rather than writing this implementation outside, you are writing this implementation within the class. You can see the message engine start and engine what here? Stop. Engine start and engine stop, right? Yes. So just try to understand here, right? Okay, right? So I'll tell you some applications of using this inner classes, and then we'll go for another chapter, which is called as exception handling. So tomorrow we'll see that, right? Today we'll stop it here, and tomorrow we'll continue this, right? Thank you. Huh? Uh, हाँ, आपका इंटर्नशिप के अब आपको ये आता है कर रहे क्या हो गया एमएल हो गया Congrats.